first compound which we are going to discuss, that is diborane. There are various kind of boranes. So it may have a formula Bn Hn plus 4 or Bn Hn plus 6. The famous one which we are going to discuss is B2H6, that is diborane. Now, what is the structure of diborane? Initially it was considered that there will be a direct boron-boron bond and one boron is sp2 hybridized. But if we consider the structure now, it is like this way. The electronic configuration of boron is 1s2, 2s2, 2p1. Now the excited state electronic configuration is like this way. So there will be sp3 hybridization. In a sp3 hybridization, boron having one vacant orbital, one vacant sp3 hybrid orbitals. So because of sp3 hybrid orbitals, so boron actually get overlap like this way. This way. And this is the vacant orbital. Now when I am saying B2H6, the another one must be like this way only. So hydrogen, hydrogen, hydrogen. Now interestingly, it is observed that these two hydrogen atoms, this hydrogen atom and the hydrogen atom which is here now from this, they are actually bridge between two boron atoms, and it is because of the vacant orbital of vacant sp3 hybrid orbital. So vacant orbital get overlap like this way. Well, here in this case this is a filled orbital, so hydrogen is over here. So now if you observe a structure, it is like this way. The electron density is actually lying this way, where two hydrogen atoms are placed. So there is no direct boron-boron bond. Two boron atoms are bonded by these bridge hydrogen atoms. These are called as banana bonds. And it is actually looking like this way. So 4 BH bonds are in one plane, while the bridge hydrogen atoms are actually perpendicular to this plane. So this BH, 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 they are planar, 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 planar and planar, while these hydrogen atoms are breached. So breach bonds which are perpendicular to the plane. So now we have to discuss what are the methods of preparations of diborane and what are the reactions of diborane. Diborane can be prepared by trifluoroborane diethyl ether, etherate we call it as a lithium aluminium hydride. So lithium aluminium hydride act as a reducing agent and fluorine is replaced by hydrogen, so that we are getting diborane. Sodium borohydride when treated with iodine, this is called a dimethylene glycol dimethyl ether, diglyme. Diglyme is a trade name. You will get diborane. Commercially, Diborane is prepared when boron trifluoride is reacted with sodium hydride at 450 Kelvin. So, this is a commercial preparation for diborane. Now, what are the reactions of diborane? Diborane is stable at low temperature. As we go on heating temperature, as we go on increasing the temperature, diborane is actually converted into higher boranes. So, as I already told you, there are mainly two types of boranes we have, BN, BN, HN plus 4, BN, HN plus 6. So, on that basis, if we heat it for about 373 to 523 Kelvin, we are getting B4H10, tetraborane, pentaborane, hexaborane and so on. If we are heating it under control conditions, that is 353 to 363 Kelvin, at 200 atmospheric pressure for 5 hours, you will get tetraborane. So, this way actually this can be prepared in the same manner. So, this is the range which is given where we are getting various kind of boranes. Borane, since it contains hydrogen, they are when they are heated in atmosphere, they burn, they catch fire immediately and we are getting boron oxide. That reaction is highly exothermic. Okay. Boron can be hydrolyzed by water, diboranes can be hydrolyzed by water and they are giving orthoboric acid H3BO3. Boron act as a Lewis acid, diboranes act as a Lewis acid, accept lone pair of electron, so trimethylamine gives you this complex. Carbon monoxide gives you this complex. Diborane when react with methyl alcohol, it has almost similar reaction to that of the water. So, in water we have H3BO3, here we have BOCH3 thrice, means we have trimethoxyborane. This is trimethoxyborane. This is orthoboric acid. Okay. It reacts with ammonia at low temperature, we are getting one complex like this way. Now, if you see here what is happening, one hydrogen atom, so actually it is a kind of a proteolysis. So, one hydrogen atom is taken up by one boron, so that you will get this anion, while NH3, one NH3 is accepted by, that one hydrogen atom is actually replaced by NH3 and therefore we have this complex. If we heat it further, we are getting this compound B3N3H6, which is called a borazine. So, the structure of borazine is like this way. So, we have H6. So, each atom is getting one hydrogen and there are alternate double bond. So, nitrogen become tetravalent. So, nitrogen carries positive charge and boron is gaining one electron. So, carries a negative charge. So, actually this is a coordinate bond where nitrogen is donating lone pair of electron to boron. Now, this structure is similar to that of the benzene. Therefore, this is also called as inorganic benzene. And there is a resonance of these electrons. Okay, borazine or inorganic benzene. Diborane when react with sodium hydride, you will get a sodium borohydride, which is a complex Na plus BH4 minus. Similarly, when it reacts with lithium hydride, you will get lithium borohydride. Now both these compounds are very important for reduction. They act as a reducing agent in organic chemistry. When it reacts with alkalis, you will get potassium metaborate KBO2 and hydrogen gas is liberated. When hydrogen halide or hydrohalic acid when react with diborane, there is a formation of a compound that one of the hydrogen atom is replaced by halogen. Here the order of reactivity of hydrohalic acids are HI is greater than, HBr is greater than HCl. Same way, when directly halogens are reacted, again the same thing, hydrogen is replaced by halogen atom. Here the order of reactivity Cl2 is greater than, Br2 is greater than I2, this way. So this is all about the reactions and methods of preparations of diborane. The important thing over here, we have to remember the structure of this borazine and heating with oxygen, preparation of sodium borohydride or lithium borohydride, which act as a good reducing agent. Few more compounds we have to discuss. One is a borax and the other one is a orthoboric acid that we'll discuss in the next session. Thank you.